All right, here's the answer for the your turn. Now, if you had some struggles with it, it's quite a lot to learn at once. So if you found yourself getting stuck and you're just looking at the answer, it's okay because you're going to have lots of time to practice it in the worksheet coming up. So in the first bit that says how long until it stops rising, here's my answer in blue. And I'll note that you only use the first half of that whole parabola because it stops rising at the top. So your initial velocity over here is going to be that 12.5, and really the key is that that final velocity is going to be equal to 0, and you really only need the y direction in your calculation, so you don't need to waste space thinking about the x direction at this point. You're going to need to use equation number 4 to calculate that, or you could just think about it logically. If it's going 12.5 and it's going to go to 0 and it changes 10 every second, you're going to say 12.5 divided by 10. So that works out to 1.25 seconds for how long it takes until it stops rising. So that's the answer for A. The answer for B, oh, and I guess I kind of skipped over the fact that here's how you figure out the Vx and the initial Vy. B asks how long will it be at this time, or how high will it be at this time. So again, we're just using that first half, and so you can use the same numbers, and what they're asking for is the delta y. You can use, now at this point, any equation except for equation number 4. I chose equation number 1. You may have chosen a different one, but you should get that same answer of 7.8. I like to leave in a lot of digits, just in case if I need to reuse that number for a later question. But if you just wrote 7.8 meters at that point, that's fine too. The last question was, how far away does the ball land? How far away does the ball land? Really, we're asking about the delta x in that situation. And at this point, you have to consider that whole path. So what I did in my question is I said, well, I had already calculated the delta t to the halfway point was 1.25 seconds. So I said, well, if I'm going to use that full path, then I need to multiply that times 2. I double the time, so I get 2.5 seconds. So that's how I got this value here. And then it becomes pretty straightforward of multiplying that multiplied by the Vx to get 54 meters. Okay, so I hope that made sense to you. And if not, well, I guess we'll see you in class. We can talk about it. Thanks.